Welcome to our course, an exciting introduction to data science with Python. We'll explore this fascinating field together. Our journey will focus on how to unlock valuable insights from data, leveraging Python as a versatile and powerful language. Now, let's explore a crucial question. Why is Python the preferred choice for data science professionals today? Python has truly become the language of choice, empowering us to derive compelling, data-driven insights effectively. Firstly, a significant advantage of Python is its remarkable ease of learning for new users. Python's straightforward syntax makes it very accessible for beginners, allowing for easy reading and understanding of code. Another key benefit is Python's incredibly large and supportive community of developers and users. This vast and active community provides extensive support, abundant resources, and constant innovation for everyone. Python also boasts an extensive collection of powerful libraries specifically designed for data science tasks. These libraries offer a rich ecosystem for data manipulation, visualization, and advanced machine learning algorithms. Furthermore, Python's impressive versatility makes it suitable for a wide range of analytical applications. It is capable of handling everything from data cleaning and statistical analysis to complex artificial intelligence applications. Finally, Python's open-source nature is a huge advantage, promoting accessibility and collaboration. Python and its incredibly powerful libraries are freely available for anyone to use, modify, and distribute. Let's now delve into the key libraries that are absolutely essential for performing data science tasks in Python. These foundational tools are indispensable for every aspiring and experienced data scientist, forming your core toolkit. First up, we have NumPy, a fundamental library for numerical computing in Python. NumPy provides support for efficient multidimensional arrays and mathematical functions, enabling much faster computations. Next, we have Pandas, which is truly essential for effective data manipulation and robust analysis. Pandas supports powerful data frames, which are perfect for working with structured data in an organized way. For creating compelling visuals, we rely on Matplotlib and Seaborn, two excellent visualization libraries. These powerful libraries help us create static, animated, and interactive data visualizations to present insights. Then there's scikit-learn, a comprehensive library for various machine learning tasks. Scikit-learn offers a wide range of machine learning algorithms for effectively building powerful predictive models. Lastly, for deep learning, we have TensorFlow and Pytorch, industry leaders in advanced AI. These are the leading frameworks for developing sophisticated deep learning models and advanced AI applications. Let's now explore the systematic steps involved in a typical data science workflow using Python. This systematic approach is crucial for efficiently extracting valuable knowledge and insights from raw data. The first step is data collection, where we gather raw data from various sources. Next, we perform data cleaning and preprocessing, handling missing values, duplicates, and inconsistencies to ensure data quality. Then comes exploratory data analysis, where we identify patterns, trends, and outliers within our dataset. Following that, we move to model building, which involves developing and training appropriate machine learning models. After building, we conduct model evaluation and optimization, assessing performance and refining parameters for better accuracy. Finally, data visualization and reporting involves presenting our findings clearly through charts, graphs, and dashboards. Today, we'll walk through a simple data analysis example to see how it all comes together in practice. This walkthrough will cover basic steps like loading data and performing initial inspections to understand its structure. First, we need to import the necessary libraries, which are essential tools for our data analysis tasks. Here, we import Pandas for data manipulation, NumPy for numerical operations, and Matplotlib/Seaborn for visualization. Next, we'll load our dataset directly from a CSV file into a Pandas data frame for easy handling. This line of code reads the data, CSV file and stores its contents into a variable called data. It's always a good practice to display the first 5 rows to get a quick glimpse of our data. The data head function allows us to view the initial entries of our dataset, confirming successful loading. After loading, we must check for any missing values, as they can significantly impact our analysis results. This command calculates the sum of null values for each column, helping us identify missing data points. Generating summary statistics gives us a numerical overview of our data, including central tendency and dispersion. The data describe function provides descriptive statistics like mean, standard deviation, and quartiles for numerical columns. Finally, let's visualize the distribution of age using a histogram to understand its patterns. This code creates a histogram of the age column, showing frequency and a kernel density estimate for distribution. Let's explore 2 fundamental Python libraries, NUMPY and pandas, crucial for efficient data manipulation. These are essential tools, providing powerful capabilities for handling and analyzing structured data effectively. First, we have NUMPY, which stands for Numerical Python, a cornerstone for scientific computing. NUMPY primarily provides support for high-performance multi-dimensional arrays, known as end arrays, which are very efficient. It's highly optimized for numerical computations and executing various mathematical functions with speed. NUMPY arrays are significantly faster and more memory efficient compared to standard Python lists, especially for large datasets. Therefore, NUMPY is best suited for complex mathematical operations and linear algebra tasks. Next, we have pandas, the Python data analysis library, built on top of NUMPY. Pandas offers 2 primary data structures: series, which are one-dimensional labeled arrays, and data frames, which are 2-dimensional labeled structures. It's specifically designed for data cleaning, flexible manipulation, and transforming raw data into usable formats. Pandas excels at handling missing values, filtering, sorting, and grouping data with remarkable ease and efficiency. Ultimately, pandas is the go-to library for handling structured data, such as tables or spreadsheets. Let's outline the systematic steps involved in exploratory data analysis, or EDA, a critical first phase. The first step is to thoroughly understand the data's structure, including its dimensions and data types. Next, we must effectively handle any missing values, deciding whether to impute them or remove them. It's crucial to check for outliers, as these extreme values can significantly skew our analysis and models. Then, we summarize the data using descriptive statistics to gain initial insights into its central tendencies. Finally, we visualize relationships between variables using various plots to uncover patterns and correlations. Now, let's dive into some core Python data operations, focusing on practical code examples. These are essential code snippets for performing fundamental data manipulation and visualization tasks efficiently. First, let's look at NUMPY array basics, which are foundational for numerical computing in Python. The NUMPY array function creates n-dimensional arrays, allowing element-wise arithmetic operations, which is very powerful. This code demonstrates creating 2 NUMPY arrays and performing element-wise addition, resulting in a new array. Next, we'll cover pandas data frame creation, a versatile way to structure your tabular data. A pandas data frame is a 2-dimensional labeled data structure, easily created from dictionaries and enabling simple column selection. Here, we create a data frame from a dictionary and then select specific columns, like name and age, for display. Moving on, let's explore creating a basic line plot using matplotlib, a classic visualization library. Matplotlib pyplot creates static plots, and plt plot generates a line chart using provided x and y coordinates. This code generates a simple line plot by defining x and y values, then displaying it with a title. Finally, we'll look at creating a histogram using Seaborn, which offers enhanced statistical visualizations. Seaborn hist plot generates a histogram to show a variable's distribution, often including a kernel density estimate, KDE. This example shows how to create a histogram of sample data, including a kernel density estimate, to visualize its distribution. We've covered a lot, so let's summarize the key points from our journey into data analysis with Python. Here are the most important takeaways and practical insights for performing effective data analysis using Python. Remember, Python is incredibly powerful and versatile for data science, thanks to its simplicity and vast collection of libraries. NumPy and pandas are fundamental. NumPy for numerical computation and pandas for efficient data manipulation, making them indispensable tools. The data science workflow is a systematic process, moving from data collection all the way through visualization and reporting insights. Exploratory data analysis, or EDA, is crucial for truly understanding your data, identifying patterns, and preparing it for modeling. Libraries such as Matplotlib, Seaborn, and Plotly are essential for effective data visualization and clearly communicating your valuable insights. Finally, remember that hands-on coding with Python libraries is absolutely essential for developing practical data analysis skills.